to our next FRQ. Now these FRQs are the short ones. They're only worth 4 points each. So 4 points, you don't want to waste a lot of time on these things. So they recommend 9 minutes for these short FRQs. There's 4, 5, 6, 7 are the short FRQs. I'm going to set my timer to 10 minutes. It's a pretty purple one. And let's see if we can get them in, hopefully before the 10 minutes is over. Timers are going. Let's see, we got, a pH curve. Yes, always have pH curves on AP exams. If you don't have one, you think, something's wrong. Here we've got a reaction between hypochlorous acid and water. That's one of the weak acids. In fact, chlorate, ClO3, would be chloric acid, then ClO2 would be perchloric acid, and then here we got hypo, even less. There's only one oxygen on this one. Reacts with water to make a little bit of H3O plus and Cl minus. This is bleach. Okay, identify the conjugate acid-base pairs. And, one. Okay, one of them. So we have to do one. Don't do more than one. I mean, if you do two and one of them is wrong, the whole thing goes. So just go one acid-base pair. Well, let's start. They give us the acid. HClO is the acid. I mean, you talk about making it easy. Now, we just have to find out the base that it turns into. And here it is. When it loses that proton, loses the H plus, it becomes the conjugate base that, if left in solution, will make ourselves a basic solution, slightly basic. Let's see, I got the charge right. If you get that charge wrong, that would be bad. I'll label it acid, and then this is the base, and I'll put a little C at the bottom. Okay, enough time on that. Good. Now, shown in the graph below, because I only got 10 minutes, is the titration curve that results. I mean, here's a point that's you don't want to miss a point like that. That's beautiful. That results when 25 mLs of 0.2 molar HClO is titrated. So we've got our weak acid volume, a weak acid concentration. Carefully draw a second curve on the graph that will result from the titration of 25 mL. So same amount. So, same volume, I should say, and same concentration. What? Let's check that. 25, same volume, same concentration, and is titrated with 2/10 molar hydroxide, 2/10 molar hydroxide. I mean, everything is the same except this is HClO4. Oh, wait a second. Remember, our strong acids are HCl, HBr, HI, nitric acid, sulfuric acid, and this is the other one. This is an acid you're not going to see much of. Perchloric acid. This is not only is it a strong acid, it's an explosive. Don't work with this unless you spend a half hour to an hour with the safety instructor on it. It's nasty stuff. But it's a strong acid. And at 2/10 molar, it's going to have a pH of about 1. I mean, strong acids, you get anything more than 1/10 molar. In fact, actually, it'd be a little bit below 1, but I'm sure they'd just give you 1 on that. Strong acids, I mean, they just pretty much stay, at this when you titrate them until they are close to their equivalence point. Then, zap, they go right up. And we know at 25 mLs is going to be, because of the same volume and concentration, it's going to be at the same point where we end up going through this. There. Now, the equivalence point will have a pH of about 7. So we're going to be right there. There's the equivalence point. The equivalence point for the perchloric is going to be a little bit basic because it's got a real base. So that's it. I mean, let me double check. We're starting at a low pH, and once it's wiped out, then we're going to have pretty much the same thing. So the only thing I look for is a pretty flat curve down here with a pH of close to 1, and then zap, moving up. Okay, HClO4. You don't see this one too often. In fact, I've worked with it once in organic chemistry class, and in another class, somebody got hurt badly with it, so we were all really, really careful. I mean, they looked like the mummy wrapped in bandages on the next day. Okay, let's go back here. C. A student proposes to create a buffer. Okay, buffer, acid-base conjugate pair involving 1/10 of a mole of, oh, wait a second. This is a strong acid. This is a strong acid. You can't make buffers with strong acids because their conjugate bases don't act as bases. I mean, you have to have some acid, you have to have some conjugate base, and this is nada. So, okay, let's see. Now, explain why the resulting solution would not be a buffer. HClO4 is strong acid, and ClO4 does not act as a conjugate base. I mean, this acid is so strong that its conjugate base is like nothing. It's like a chloride. It's, in fact, actually, it would be a spectator ion, except it's explosive. It's a spectator. Okay, wait a second. Oh, we got 1 point, 2 points, 3 points. Is there anything else? Wait, is that it? That can't be. No? Let me double check. Acid base, this. Okay. That's it. There's nothing else to deal with on this question. It's over. Titration curve, I did everything right. I'll double check. It's only been a couple of minutes. No, not here. I've got everything there. This is a strong acid. Yep. And it would change to 25 mLs, just like everything else. Concentration times volume equals concentration times volume. Student proposes. That's it. Probably 1 point for this. My guess is 2 points here. And then another point here. So that's 4 points. That's it. We're done. Nada. We didn't take our 10 minutes. So let's finish this one.